Keep it going. Keep it going. Skoden. 403 to the HAZ. Mr. Nelson here. We are talking about slope. Essentially, we're talking about slope right now. We're talking about linear equations. Equations that represent lines that essentially can go on forever in each direction if we give them the domain to do that. This is the equation of a line. So B is our y-intercept. B is where our line crosses the y-axis. B can be 0, and if B is 0, it means it crosses the y-axis at the origin, at 0, 0. If M is 0, it just means that we don't even have, we just have a straight line, okay? So an example of a slope of 0 is y is equal to 5. In which case, I don't have an x, so I have to assume that 5 is b, and then an equation like this would just essentially look like a straight line at 5 that just goes on, because basically y is always equal to 5. That's just what it means. It's always equal to 5. Y is just 5. So that's not really, doesn't do anything for us. So that's when I have a slope of 0. If I have a slope of 1 and no y-intercept, that's just my basic y is equal to x, or an invisible 1x. So that means that I have basically every y is equal to the same x. And when we're calculating slope, we're always taking a data point to the right for the x2, y2, and we're subtracting that from a data point further to the left. And if going from left to right, if my line goes up like that, it means I have a positive slope. And if going from left to right, my line is going downwards, like a downward ramp, then my slope will always be negative. If my line is going down from left to right, from negative x to positive x, it's a negative slope. So now we're going to introduce two more concepts that we can kind of consider when dealing with lines. Parallel, I think that's how you spell it. Parallel and perpendicular. Perpendicular. Okay. Parallel. Think train tracks. Parallel means same slope. Same slope. And they remain always the same distance from each other. Just think train tracks. Parallel lines are lines parallel lines can happen any direction, and all they mean is they're always the same distance away from each other, which also means that they always have the same slope. Okay? They might have different y-intercepts, but parallel lines will always have the exact same slope. And because of that, they will never cross. Parallel lines will never, ever cross. Train tracks never cross, and they are the best example of parallel lines. They always remain the same distance apart, because if they didn't, we would have derailments all the time. Okay? Parallel lines will never cross. Any other two equations of lines, as long as they're not perfectly parallel, so say I had two lines like this. Now, let's say the slope of this one was, I'm pulling a number, say that slope was 3, and this slope wasn't exactly 3, so it wasn't perpendicular, it wasn't perfectly parallel. Say it was something like 3.1. They're almost the same slope, but they're not quite the same. And because this one is always riding at just 0.1 more than the other one, eventually, because they're not parallel, eventually at some point, down the road, or they will cross, they will intersect. It's only parallel lines that will never intersect. Hopefully I've made that clear. Perpendicular lines basically means two lines that cross as a T, as a perfect T, okay? Or at 90-degree angles, okay? Perpendicular lines are two lines that cross each other at perfectly 90-degree angles. That's what perpendicular lines are. And basically, the slopes of perpendicular lines are negative reciprocals. Okay? Now, the really complicated jargon to just explain to us that for two lines to be perpendicular, then one, if this is, I'll just do an example. Say this is a slope of 2. Well, if this line is perpendicular, it's going to be 1 divided by whatever slope this is and negative. So this will have to be negative 1 over 2. First I flip it, I do 1 divided by this one, and then I take the negative. Now these two are perpendicular lines. Let's say I had, let's say this one was negative 5 slope. It's going down, so it's a negative slope, and let's say it's negative 5. What would this one have to be perpendicular? Well, to find a perpendicular line, we just divide the one we're trying to perpendicularize, the one we're trying to intersect perpendicularly. We take whatever slope that is, we divide 1 by that, so it's 1 over negative 5, and then we take the negative of it. So what's negative 1 over 5? It's 1 over 5. So this will have to be a slope of 1 over 5, positive 1 over 5, to be perpendicular to that one. Okay? The negative reciprocal. That's how we can figure out if they are perpendicular. So, let's say I had, let's do one more for good measure. Okay? So what if I had a slope here? This one was, let's say, 3/2. Okay? This has a slope of 3/2. What will the slope of this guy have to be perpendicular? Well, I have to flip it. So before, if I had a slope of 2, I would do 1 divided by 2. Basically, I'm just saying, what I'm doing is I'm flipping it, because 2 is the same as 2 over 1, so I just flip it. Same thing here. If I have 3 over 2, I flip it, and then I just take the negative. So it becomes 2 over 3 when I flip it, and then I take the negative. That's the negative reciprocal. Okay, so let's talk about perpendicular and parallel lines now and how to identify them, essentially. So we know that parallel lines have the exact same slope. So let's say I had equation of two lines. My first equation of my line was 2x minus 5. And then let's say I had a second equation of 2x plus 1. And I ask you, are these lines parallel? Because they have different equations, okay? So are they parallel? Well, you have to ask yourself, well, do they have the same slope? Okay, well, what is the slope of these lines? Well, I have to look. The slope is always going to be the number that is married to or tied to the x, okay? So in this case, 2 is beside the x, so 2 is my slope. In this case, 2 is beside my x, so 2 is my slope. So in both these cases, they have the same slope, but they have different intercepts. This one has a y-intercept of -5, which means it crosses the y-axis at -5, and this one has a y-intercept of +1. Now, I could have also written both of these equations like this. Y is equal to 1 plus 2x. And what often happens is kids or students say, okay, well, the first number I see is 1, so that must be my slope. No. Slope is always connected to my x. They might change the order, in which case now this is my y-intercept, this is my slope. But my slope is always tied to x, and my intercept is always just a number. Something important to note. So I say, okay, well, these both have exactly the same slope of exactly 2, so yes, they are parallel, And if I was to graph them, it would look something like this. This guy would look like this. It's going to cross the y-axis at -5 at a slope of, +2. So it's going up, okay? This guy is going to be parallel, but it's going to cross the y-axis at a +1. So it should look like that. So that's what these two equations will look like. They're going to have the exact same slope of 2, which means they rise 2 for every 1. They go up 2 points for every one to the right there. It's rise over run. And so, sorry, that looks like this. So a slope of 2 will be, you go up 2 for every 1 here. Okay, that's a rise, a change of 2 over a change of 1. Change in x, change in y over change in x. So yeah, so they're both exactly the same slope. So they're always the same distance. They're never going to intersect, but this guy crosses the y-axis at -5, at y is equal to -5, and this guy crosses the y-axis at y is equal to +1. Those are parallel lines. Now, let's say I say, okay, I have the equation of a line of 3x minus 2. And I say, what is the slope of a line that is perpendicular to this line? Well, if I want to calculate that, I first have to identify, well, what is the slope of this line? The slope of that line, what's the number that's beside the x? It's 3. So the slope of that line is 3. So perpendicular means I do the reciprocal, I flip the fraction, and remember this is invisible over 1. That's going to help, right? So this is 3, aka 3 over 1. So I'm going to flip it and then take the negative. So the slope of a perpendicular line is going to be, flip it, 1 over 3, negative. So the slope of a line perpendicular to this equation is -1 over 3. That is perpendicular versus parallel, okay? So this line is going to cross the y-axis at -2, because that's my intercept. It's going to have a slope of a +3, so it's going to, from left to right, it's going up. So it's going to look something, that's a pretty steep slope, 3. So it's a change of 3 in the y for every change of 1 in the x, right? That's what that slope means. So this point, if I started here, this should be a change of 3 from here to here. And from here to here, it should be a change of 1. That's a rise over run of 3, of a slope of 3. And then so obviously the line that's going to be perpendicular to this one is going to look something like this. Now, I don't know what the y-intercept will be. I haven't gone that far, because this line could intersect anywhere along here. But all I know is that it's going to have a slope of -1/3 in order to intersect at a perfect right angle. So figure out how you're going to remember this stuff. Parallel flows, it's nice and easy. Perpendicular is very, as a word, it's very kind of confrontational. So hopefully that makes sense. There's a lot to talk about, so we're going to keep building on this knowledge.